Right, it is 5mm totally once. So we need to take it back across that way, 2.5. We're getting out of sync here. Start again. I'm going to clock this in through and then start again. Right, we're back to running through. So we need to offset it now. 2.5mm. Bring the clock gauge in. It's 0. That's there. Then it wants to come towards me. 2.5mm. I'll loosen that one off. Tighten the other one. Nearly 2. Just about there. Right, I think we've got it now. The little pointer is on 1, the big one's on 0, so that's 1, 2, 3, 4, 5.5 in a fanny's hair. I'm going to settle for that. Otherwise I'm going to be on all day. Right, so now we've got the 2.5 offset, which is a 5mm, because it's 2.5mm a side. So we'll drill this to the right diameter and then pop them off. Strange having a workpiece revolving off centre that much. The 10mm hole is just for a 10mm bolt, so it hasn't got to be reamed to size. I'm sort of overcomplicating this job a little bit, I think. I bought some Dormer twist drills, some second-hand ones, and they seem to be really sharp. As you can see, they're cutting really nicely. Quite interesting grind on the end of them. Make sure that the bottom tool is at 90 degrees to the job. The longest one 30, so I'll take the longest one first. I'll cut it longer than 30, and then we can put it back in and trim it to length. We'll go 31. 31's there. Doesn't do any harm. Have a measure. Good 30mm. Parting this off is going to be an interrupted cut, so this is going to be interesting. Something I've never really done before. nice and gently. In actual fact, now that I've got this offset, I could put it in an ordinary lathe chuck and just part it off, and then it wouldn't be doing what it's doing now. We'll carry on with this one. It's still going to be offset when it hits the hole, but it won't. If I do it this way, it'll part off clean to the hole. The other way, the hole will be running offset. Less of the two wheels, I suppose. It's doing alright. It will start to be a continuous cut before we get through to the hole. I'll actually speed it up now. It's doing a full cut, but it's doing alright. I'm not in any great hurry. Right, there's one. Next one's 15. We'll make it just over 16. There's enough to machine both sides. I've got enough, more than enough. Make sure you wind it back before you start the lathe up, otherwise it's going to have the end straight off the tool. There, you can hear it. This chuck now goes back on true for some reason. I don't know if it's the taper's wrong on the back plate. It goes on very near, but it doesn't go on perfect. Put a little test piece in. Put a clock here just to have a make sure. See, it's not right. It's not far away, but it's not right. When I fitted this chuck, initially I did make the recess in the centre, or the spigot in the centre, a loose fit. I've done this before with 3-jaw chucks and had no problems at all. It means you can set it up and get it spot on. And once it's set up for this particular size, it is accurate through the full range. So we'll loosen them off. Simply rotate it, we'll find the high point, which is there. It's not far away, it's just a funny's hair, but it's not right. Right, you can see that there. Nice and true. Tighten it up. It only takes seconds to do this really. It's not a difficult job. It certainly isn't tool room practice, but this isn't a tool room, and for me pissing about, it certainly gives accuracy that I need. Right, spot on. See the gauge there, barely moving, or not moving at all. It's got to be 30, it's 31.58, so we'll take 1.5 off it, and then chuck cage on. It's a nice gentle grip, we don't need to go stupid. Just where the digger comes in handy. There's one. Right, 1.5. Little chamfer on there. Drag that hole, and that's the first one done. Right, so that's nearly kicking the arse off. This one needs to be 15, so we'll face one end first and put a chamfer on it, and then machine it down to size. Right, so we've got 16.7, so only 1.7 taken off. There's one. .7. Right, so 1494 is good enough for an alternator adjuster. Once again, time to use my dad's drill. Every time I use this, obviously I think of my dad. It's ideal for putting chamfers on little parts like this, just to finish the job off nicely. Spot on. That is several different ways of testing welds. You can x-ray them, you can section them and die penetrate them. What I'm going to use is a weld proving method. It's called the FBH, fairly big hammer. We'll put it in a vise and we'll give it a little bit of a knock and see what sort of result we've got. I think I may put the vise on the ground because this is going to get a little bit exciting here. Right, I've had enough of that. I didn't go nowhere. Once again, it's just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do so because we're all getting near to 100,000 views. Anyway, thanks for watching.